Hello and welcome to the podcast on thermodynamics, Hess's Law. Alright, so I have a series of problems here. If we remember, Hess's Law basically says that we're going to take an unknown reaction, one that we aren't sure of a delta H or an enthalpy value for, and we'll use a series of reactions that we do know. So if we look at this problem, we are looking for the delta H for this reaction right here. I'll highlight it. So that's the overall reaction, and we want to solve for the delta H value for this reaction. So that's what we're looking for. And in order to do that, we're going to use these series of 3 reactions to be able to find our unknown. So these are the 3 that we're going to use. All right, so what we have to do is we have to go through and make these 3 reactions add up to this reaction exactly. So if we look at this first reaction here, and you don't always have to go in order. Sometimes I skip around. But one of the things that I do is I kind of scan through. And I look and I see, okay, well, I know I'm going to need N2. Where is the only place that I have N2 gas? And it's very, very important with these problems that you're taking a look at the subscript for what state of matter it's in, because sometimes you'll have liquid versus gas for water or for whatever it is. It has to be the right state of matter. So this is N2 gas, this is N2 gas, great. We have one of these, we have one of those. So we know that we're going to need this reaction exactly as it's written. Okay, so we'll move on to the next reaction. And if we take a look at the next reaction, we have NO2 in the product side, and we have NO2 in the product side, and it's a gas. This is a gas, and we have 2 and 2. So this one we're going to use as it is. This one we're going to use it as it is. Okay? Now, the only one we have left is oxygen. Let me change the colors just so you guys can see. All right. So if we look here, we have oxygen on the reactant side, and nowhere else do we have oxygen in the first 2 reactions. So it's always good to double check, because sometimes oxygen you'll find in multiple ones. We have O2 here, but there's 2 issues. Number 1, it's on the product side. Number 2, we have half oxygen. We need it to be 2 oxygens. So what we're going to do is we're going to take this and we're going to flip it. Whenever we flip it, we're going to take whatever the sign is and we're going to change it. So this was negative, it's now positive. And we're also going to multiply this by 4. So we're going to flip it and we're going to multiply it by 4. Okay, so when we flip it and we multiply it by 4, I'm going to cross it out so that I can rewrite it. If I'm just multiplying by 4, I'll just put the numbers and change them in there, but when you flip it over, you have to rewrite it. So now you're going to have 4H2 plus 4 times a half would be 2 O2. And if I had them in multiple states, like if I noticed here I had liquid water and gaseous water, I'd also rewrite them, but here it all is going to work out, so it's not necessary. And that's going to be 4H2O. Okay, so now just to double check, and honestly this step is not required if you think you've got everything right, but just to double check and make sure we're doing it right, these should add up to exactly this. Okay, so let's see what we can cross out. On this side, we have 2 NH3s right here, but we also have 2 NH3s. This one's on the product side, this one's on the reactant side. We can cross this out. If we look here, we have 3 H2 gas. Here we have 4 H2 gas. That would be 7 on the reactant side. And we've got, look, 7 on the product side. So that should cancel out. Okay, let's look for the waters. We've got 4 waters here, 4 waters here. Those are going to cancel out. So now let's go through and see what we have left and make sure it's right. So what we have left is N2, we want that. Okay, nothing left there. And O2, we want that. And O2, we want that. So when you add it up, you get N2, it's a gas, I'm not going to write that, plus 2O2, also a gas, gives us 2NO2 also a gas. And if we look, that's exactly what we had up here. And now our job is just to add up the delta H's and get a value. So we would have this one plus this one plus this one times 4. And I'm going to put it in my calculator. And so in the end, we're going to get delta H for our reaction is equal to negative 82, oops, I can't see the 2.7 kilojoules. Now, sometimes you'll get kilojoules per mole, but because, that's a lowercase k, by the way, it's just hard to write it. If you look here, if these are kilojoules, then your answer is kilojoules. If this was kilojoules per mole up here, then you would get kilojoules mole per answer. Okay, so this lets you know that your reaction is exothermic, which in this case we don't really know this reaction, so we don't know if that really helps us or not. But all right, let's take a look at the next one. Okay, so it says find delta H for the reaction below. So that's going to be our, draw this here. Oops. All right, so I just highlighted that a little bit neater. So here's the reaction that we want to solve for delta H for, and we have these 3 reactions to work with. If we look here, we have to be really, really careful because we've got both H2O liquid and H2O gas. And that's going to be really important because in our answer, we want H2O gas. We want to get rid of the liquid. We want to make sure that doesn't appear, but we want to be able to keep that gas because that's part of the final reaction. So we're just going to be really careful to, whenever we write it down, to make sure we note that. All right, so let's take a look at our first reaction. And if we notice here, we've got this in the product, sulfuric acid, liquid sulfuric acid. But up here we've got it in the reactants. So we know this is one that we're going to have to rewrite because we're going to flip it over. And when we flip this over, we have to change the sign to positive. Don't forget to do that when you flip the reaction over. So when we flip this over, we're going to have H2SO4. We're going to have to write the liquid this time because states of matter is really going to matter. Ha ha ha. H2S gas plus 2O2 gas. All right, let's take a look at the next reaction. If we look at the next reaction, we have got let's change the color here. HSO3. Up here we've got HSO3. They're both a gas and they're both exactly how we want them. So we're going to leave that one alone exactly how it is. All right, so now if we take a look at the reactions that we have, the one thing that we're missing is right here. We're missing the H2O gas. We've got H2O liquid, but we want H2O gas. So if we look at this final reaction down here, this will get rid of the H2O gas and it will add in the, get rid of the H2O liquid, add in the H2O gas that we want in our final reaction. And since this is 1 and this is 1, we can just leave it exactly how it is. So now all we have to do is add up the sum total for our reactions, and I'll change colors here. All right, so if we look here, we can cross out oxygen, the 2 oxygens, because this is on the reactant side, this is on the product side. We can also get rid of H2S, because this is on the reactant side, this is on the product side. And if we look here, we can get rid of H2O liquid, Okay, and so what we're left with is hopefully what we want in the end. So we've got, for this reaction, we've got this, and this. And so when we add it up, we get H2SO4, liquid sulfuric acid. And that's going to give us SO3 gas plus H2O gas, and our final delta H value is 70, oops, 70, 72.5 kilojoules. And this would be endothermic because you have a positive delta H value. All right, we've got one last practice problem. Okay, and if we take a look, I just erased the top, the answer to the previous one was on there. All right, so if we look at this one, wow, we've got a big long reaction here. It's all of this. All right, so let's take a look at the N2H4. So that's going to be right here. So what we notice is this is on the reactant side, this is on the product side, so we're going to have to flip it. Whenever we flip it, we have to flip the value of delta H, so this becomes negative 22.5 kilojoules. Okay, and when we flip it, I traditionally like to rewrite it. So, and in this case, there's no real difference between liquids and gases if we just kind of scan through, so we don't have to include those just to make it a little easier to write it. We end up with N2H4 plus H2 gives us 2NH3. And one of the things just to kind of highlight for you, if you look here, see this 3H2? You've got H2 here, you've got H2 here, and you've got H2 here. Trying to figure out how to make this 3H2 is going to just cause a lot of problems. So leave that till the end, and it hopefully will work out. All right, so if I look at the next reaction, I notice here I've got N2 right here, and this is the only place where I have N2. It's on the product side. I also have it up here on the product side. I'm going to leave that reaction exactly how it is. If I come down to the next reaction, I notice that my C2H0 is on the reactant side, but up in my final reaction, it's on the product side. So that means I've got to flip this reaction over. That also makes sense for the CH4O. If we look up here, this one's on the product side, this one's on the reactant side, so we'll flip it. When we flip it, that means we're going to make this a negative. That's my negative sign, and I'm just going to rewrite this flipped over. All right, so now let's make sure that everything cancels out and works out. So the first thing I notice that I can get rid of is the NH3 because I've got it on the product side here, and I've got it on the reactant side here. The trickier one is going to be the hydrogens because we've got hydrogens going on both sides. So let's go through and actually circle everything that we're going to keep. So it's kind of the only thing left are going to be our hydrogens. So we know that we are going to want to keep the N2, so that's there. We know we've got that. The NH4, that's there. This is here. This is just, by the way, to double check. This actually isn't even necessary if you think you've got it right. All right, so we've got everything. And if we look here, we've got the 3H2. And that's really what we want here, but we've also got it here and here. But what you'll notice is that it's one on this side right here and one on the product side. So you've got one on the reactant side, one on the product side. So they actually will cancel out and we'll end up back to our original reaction. I'm not going to rewrite it in this case. And then all we need to do is add up the values for the delta H. So we're going to get delta H for our reaction is negative 46.2. So this would be a exothermic reaction. That's our final answer.